Today we're doing section 11.3, and again we're working on this idea of limits and continuity for our second day. So here it says determine for what numbers, if any, the following function is discontinuous. So we're going to kind of go through that three-step process using this piecewise function to determine if there's any discontinuity without looking at a graph. So the first thing we have to check is f defined at a. So notice that there's two cutoff values. I have a cutoff value at 0 and I have a cutoff value at 1. So those are those two areas we're checking. So f of 0, so the place it would be defined at is in that top function. So f of 0 is equal to 2. And the other spot we're checking at is 1. And f of 1 is defined in that middle piece, and the output is equal to 2. So we know it's definitely defined. So now the next thing we need to determine is, does the limit exist? So in order for the limit to exist, it has to approach the same thing from either side. So as I approach 0 from the left, it would be in the top piece, and the function would be equal to 2. As I approach from the right, I would be in the middle piece, and again it's equal to 2. So overall the limit as x approaches 0 is 2. So now for our next one. So as we approach 1 from the left, I'm on that middle piece. So the function, it's just a flat constant of 2. As I approach 1 from the right, I would plug it in, so 1 squared is 1 plus 2 is 3. So as I approach 1 from the left versus the right, they're not the same, so the limit does not exist for f of 1. So overall on the back page, it needs to know if the limit as x approaches a and f of a are the same, then they are continuous. So for this side of the answer, we got the value of 2. Change that marker. I got 2, and on the limit, we got 2. So it's continuous at the x of 0. Now, because for 1, so for the left side we got does not exist, and f of 1 was 2. So it's definitely not continuous. We would say it's discontinuous at x equals 1. So that's the overall idea of the lesson. I just realized I spelled this really wrong over here. It should be U-O-U-S. Sorry for that. So let's go ahead and try one more. So again, here's another piecewise function. So first we got to determine if it's defined at our a value. So we're determining f of 3. So f of 3 will be in this bottom piece right here, and it would be 6. So now we got to determine if the limit as x approaches 3 exists. So regardless if we go from the left side or the right side, I'm still going to be in the top piece. We got to do some factoring here. So obviously if I plug it in, I'll get undefined. That top is the difference of squares, so this will be x plus 3 and an x minus 3 for the numerator, which means in the denominator I can cancel these out, and I'm left with an x plus 3. When I plug in the value of 3, I get 6. So we would say it is continuous at 3, and so essentially that was the only key value we had to check, is because that's where with your piecewise function, that's a cutoff value. So if it's continuous at 3, then you would say it's not discontinuous anywhere. So let's do one more. So here notice it's not presented to you in a piecewise manner, so we have to determine our cutoff value. So this is going back to a while ago, but to determine our domain, it's going to be every value except what will give us 0 on the bottom. So right now, the two values that would give us an undefined answer are -2 and 5. So those are the two values that are not included in the domain, which means those are potential asymptotes. So we need to check those two values for discontinuity. So first, I would find f of -2. So notice when I plug it in, I get d and e. As far as the limit goes, as I approach -2, so I can cancel those out, so I'm left with 1 over x minus 5, and when I plug this in, I get 1 over -7, and because these two things are the same, we would say discontinuous at -2. And we're going to get a similar result for the next one, so f of 5 is equal to, and actually I really should have said d and a, I should have said undefined. So f of 5 is undefined. The limit as x approaches 5 is going to be d and e. And then it's, so because they don't match, it's going to be again discontinuous at 5. So essentially, if it's not defined in the domain, you can pretty much assume it's going to be discontinuous. So that's all for today.